Hello and welcome to the first of our monthly New Scientist vodcasts. This month we attended an unusual festival that celebrates not music or art, but insects. Valerie Jameson tells us more.
I'm here at Festival in London's South Bank. Now, one of the main attractions here today is this giant wooden termite mound, and I'm here with Rupert Soar, one of the engineers who designed it. Rupert, how did the termite mound come about?
It's been a process of going out and studying termites over the last 5 years or so. Essentially all this is a digital model or a scan of a termite mound that we took from an actual mound in Namibia, and then essentially took a little part of that mound structure and scaled it up to this monstrosity that you see behind me.
Well, why don't we go and have a look inside? What you're hearing is a recording of the sound inside a termite mound. Soar's team discovered that these pulsing low resonance notes drive gas exchange in the mound.
In fact, it's true breathing in the same way that we breathe air in and out of our lungs, whereas we use muscles. Termite mounds build mounds that use sound, the resonance, to drive the gas in and out.
Another of the star attractions here at Festival is this bee cab, and I'm here with the designer Steve Benbow. Steve, tell me, why did you design this amazing London taxi?
Well, London taxis are very similar to bees, the way they sort of weave in and out the traffic. And it was designed to be used as an outreach project for schools, for education reasons, to go into schools and to start teaching people about the plight of bees in this country.
Now, you've been an urban beekeeper. What's that involve?
I started keeping bees on the roof of my flat in Tooley Street about 15 years ago, and it's a fantastic place to keep bees in London. There's full of amazing flowering plants and trees, and I think it's a great place to go back into the city and start to keep bees when bees are really struggling in the countryside in this country.
Here at Festival's the first insects that I've seen today, and here's a box of 300 or 400 mosquitoes, and if I stuck my hand in here I'd certainly be bitten by them. But I'm here with James Logan from Rothamsted Research, who's been investigating why some people are bitten by mosquitoes and others aren't. So tell me, James, what's the secret behind repelling mosquitoes?
Well, everybody thinks it's to do with the blood type that you have, but in fact it's all to do with the way you smell. And what we've found is that people who don't get bitten are producing natural repellents, almost as if their body has a natural defence against mosquitoes.
So what's the secret of the repellent?
Well, we don't quite know why the repellent is produced, but we certainly know that there are certain chemicals that are produced in much higher concentrations in those really lucky people who never get bitten.
Festival's brought together artists, scientists, engineers, and of course creepy crawlies. The festival celebrates insects and their world, and also the impact that humans have on their lives too. This is Valerie Jameson for New Scientist at Festival.
Next we take a look at some dinosaurs, or at least some life-size replicas of them. The theatrical version of the BBC TV series Walking with Dinosaurs has just started its European tour. But we wondered just how realistic these dinosaurs are, so we turned to a biologist for some answers.
Well, what did I think of it? I think it's, to put my grouchy scientist hat on, it has its good and its bad sides. In terms of the good, it's great entertainment. I think no one can really deny that it's impressive. The animatronics are very modern and gorgeous. The anatomy, scientifically, looks really good. Looks like what we think these dinosaurs looked like in general. Instead of going with your classic drab gray-green dinosaurs, they've put some variation in color, some splashes of bright color. These animals probably did have color vision, so why not give them some color? In terms of the bad, well, yeah, you could quibble over the dinosaurs looking a little rubbery and stuff. They're not moving as fast as some of these dinosaurs, especially the smaller ones, might have done.
Hutchison has his own computer models of how dinosaurs might have moved. This one is of the body of a T-Rex seen from the side. It was created using real measurements from a relatively intact T-Rex skeleton.
We had flesh because we don't know how much flesh there was outside of the skeleton, so we have to play around with it a bit. It's not a very exact procedure, but we can get very specific measurements of how much it weighed, whether it was front heavy or back heavy. We can use this kind of model to make those estimates.
Hutchison's simulations incorporate what we know about how living animals move. This model of an ostrich running shows its bones in white and individual muscles in red. Simulations like this help inform dinosaur models such as this one of a T-Rex running.
We can find the exact same muscle with a scar on the bone that corresponds to the scar that we see in a T-Rex pelvis on an ostrich. So we can see that there was basically the same muscle in the same place in a living bird and a T-Rex, which helps us reconstruct the dinosaur's anatomy with some confidence.
Hutchison recently worked with animators to create this simulation called Be the Dinosaur. By recreating the environment where T-Rex would have lived, they hope to educate museum goers about life in the Cretaceous.
Plants, the landscape, the animals, even the little tiny animals, insects and stuff, are all based on real fossils that we know are of animals that existed 65 million years ago alongside T-Rex. So we have a realistic depiction of their environment, and then you get to run your dinosaur around that environment and get a feel for what it was like to be the dinosaur in that virtual environment. It's not a computer simulation with all the physics involved, but there's enough science there that we can say, well, this is a pretty good rendering.
Although walking with dinosaurs will appeal to those looking to be entertained, Be the Dinosaur will provide a more informative approach. And since it's a traveling exhibit, it could be coming soon to a museum near you.
Finally, we head to Cornwall in the UK, where two pinhole photographers have been working on something big. Sandrine Kirstemont takes up the story.
This may look like an ordinary tent, but in the 15th century when this manor was built, it would have been a cutting-edge physics lab. Photographers Justin Cannell and Jamie House chose this site in Cornwall to build England's largest camera obscura. Using a single pinhole, they created an upside-down image of the manor. In another experiment, sunlight was directed through a pinhole with a mirror. A prism interacted with the rays on the other side.
This is basically making a spectrum from white light, but it's the same experiment that Newton did really to discover what coloured light was as much as anything else. He worked out from there that white was made up of several different types of light of different wavelengths, and people have been looking at sort of light and wavelength waves ever since.
Other setups also produced interesting results.
I made this by using many small holes there, and then on top of that I put varying focal lengths of lenses, and this focuses light and produces quite a sharp image. This rear projection camera obscura could be made at home very easily.
Outside, the pair set up a primitive sundial.
What people can do here is at midday actually find a noon mark and position a small tab at the point where there's a hole. Jamie's going to have a go at placing the date. If you do a point midday every single day and it's sunny, you'll end up with this figure of 8, or an elema they call it, and that shows the sort of it's not completely an even figure of 8, it's the actual fact that the Earth is wobbling on its axis a bit.
These simple setups can easily be reproduced at home. The pair hopes to inspire people to follow their example and experiment with light.
That's all for now, but there are lots more videos on our website. You can see what might happen if an asteroid were to collide with the Earth, or get a preview of a new cell phone app that gives on-the-spot information about the world around you. Thanks for watching, and see you next time.